Close your eyes and try to imagine absolutely nothing. Not darkness, because darkness is something. Not empty space, because space itself doesn't exist. No time, no matter, no energy, no possibility, no potential. True, complete nothingness. Tonight, we're going to explore the most profound question humans have ever asked. How did everything begin? Not just our planet, not just our solar system, but literally everything that has ever existed or ever will exist. This is the story of the Big Bang, the moment when nothing became everything, when time itself began ticking, and when the universe started its incredible journey from a point smaller than the smallest thing you can imagine to the vast cosmos we see today. It's a story that sounds like the ultimate fairy tale, but it's supported by the most rigorous science humanity has ever developed. So, settle in, let your mind expand with the universe, and prepare to discover how you came to exist in this magnificent cosmos. Before we journey to the beginning of time, let's explore how scientists discovered this incredible story. After all, no one was there to witness the Big Bang. So, how do we know it really happened? The first clue came in 1929, when astronomer Edwin Hubble made a startling discovery. He found that distant galaxies were moving away from us, and the farther away they were, the faster they were receding. It was as if the entire universe was expanding. Imagine inflating a balloon with dots drawn on it. As the balloon expands, every dot moves away from every other dot. This is what Hubble observed happening to galaxies. The universe itself was growing larger, which meant if you ran time backwards, everything would come together at a single point. The second major clue came in 1965, quite by accident. Two scientists, Arno Penzias and Robert Wilson, were testing a sensitive radio antenna when they detected a faint background hiss coming from every direction in space. At first, they thought it was interference, maybe from city lights or even pigeon droppings on their equipment. But this cosmic microwave background radiation, as it's now called, turned out to be the afterglow of the Big Bang itself, still echoing through the universe nearly 14 billion years later. The third piece of evidence comes from the abundance of elements we observe in the universe. The Big Bang theory predicts exactly how much hydrogen, helium, and lithium should exist. And when we look at the cosmos, we find precisely those amounts. It's like finding a recipe that perfectly explains the ingredients in a cosmic soup. These discoveries, and many others, convinced scientists that our universe had a definite beginning, a moment of explosive creation that we call the Big Bang. Now, let's journey to the ultimate beginning. Scientists call this moment T = 0, the instant when time itself began. But what exactly happened in those first precious moments? At the very beginning, the entire universe was compressed into a singularity, a point infinitely small and infinitely dense. All the matter and energy that would ever exist was concentrated in a space smaller than the period at the end of this sentence. Then, in an instant, space itself began expanding. This wasn't an explosion in space, but rather the expansion of space itself. Every point in the universe began moving away from every other point, carrying matter and energy along for the ride. In the first fraction of a second, something extraordinary happened. The universe underwent a period called cosmic inflation, where it expanded faster than the speed of light. In less than a trillionth of a trillionth of a trillionth of a second, the universe grew from subatomic size to larger than a grapefruit. This might sound impossible, since nothing can travel faster than light. But remember, space itself was expanding. It's like being on a moving walkway that suddenly starts accelerating. You're not moving faster than light, but the walkway is carrying you at incredible speeds. During these first moments, the universe was unimaginably hot, trillions upon trillions of degrees. At these temperatures, matter as we know it couldn't exist. Instead, the universe was filled with pure energy and exotic particles that existed for only the briefest instants before transforming into other forms. As the universe continued expanding, it began cooling, like steam, cooling into water, then into ice. And as it cooled, the fundamental forces that govern our universe, gravity, electromagnetism, and the nuclear forces,
began to separate and crystallize into the laws of physics we observe today. As the universe continued to expand and cool, something remarkable began to happen. For the first time, actual matter started to form from pure energy. When the universe was about 1 second old and had cooled to about 10 billion degrees, the first stable particles began to appear. Protons and neutrons, the building blocks of atomic nuclei, condensed out of the cosmic soup, like raindrops forming from invisible water vapor. But there was cosmic mystery unfolding. According to our understanding of physics, equal amounts of matter and antimatter should have been created. When matter meets antimatter, they annihilate each other in a flash of energy. If this had happened completely, the universe would contain only energy, no matter at all. Somehow, there was a tiny imbalance. Just one extra matter particle for every billion matter-antimatter pairs. This minuscule asymmetry allowed matter to survive the Great Annihilation and eventually form stars, planets, and you. During the first few minutes of the universe's existence, another crucial process began. The temperature dropped enough for protons and neutrons to stick together, forming the first atomic nuclei. This process, called Big Bang nucleosynthesis, created hydrogen, helium, and a tiny bit of lithium. Think of this as the universe's first chemistry lesson. Simple nuclear reactions cooked up
the light elements that would become the raw materials for the first stars. About 75% hydrogen, 25% helium, and just a trace of lithium. But the universe wasn't ready for atoms yet. It was still far too hot for electrons to settle down around these nuclei. For now, the cosmos remained a glowing fog of charged particles, opaque to light, like being inside a glowing cloud. After the excitement of the first few minutes, the universe entered what astronomers call the Dark Ages. For nearly 400,000 years, the cosmos was dark and featureless, slowly cooling as it expanded. During this period, the universe was still too hot for atoms to form. Electrons couldn't stay attached to nuclei because there was too much energy knocking them apart. The universe was filled with a fog of charged particles that scattered light in all directions. But then, when the universe was about 400,000 years old, something beautiful happened. The temperature finally dropped to about 3,000 degrees, cool enough for electrons to settle into orbit around atomic nuclei. This moment, called recombination, was like the universe suddenly clearing its throat. For the first time, atoms could form. Hydrogen and helium atoms began appearing throughout the cosmos, and suddenly the universe became transparent. Light that had been trapped and scattered for hundreds of thousands of years was suddenly free to travel. This is the light that Penzias and Wilson detected as cosmic microwave radiation. It's the baby picture of our universe, showing us what the cosmos looked like when it first became transparent. But even though the universe was now transparent, it was still mostly dark. There were no stars yet, no galaxies, just vast clouds of hydrogen and helium drifting in the cosmic void. The universe had become a dark but peaceful place, waiting for the next chapter to begin. Gravity, patient and persistent, was already at work. Tiny variations in density, barely detectable ripples in the cosmic smoothness began attracting more matter. Like seeds of future galaxies, these small density fluctuations would grow over millions of years, eventually becoming the cosmic web of galaxies and stars we see today. About 100 million years after the Big Bang, the universe experienced its cosmic renaissance. In the densest regions, where gravity had concentrated matter, the first stars began to ignite. These first-generation stars were unlike any stars that exist today. They were enormous, hundreds of times more massive than our sun, and burned with incredible brilliance. Astronomers call them Population 3 stars, the cosmic pioneers that lit up the dark universe. These stellar giants lived fast and died young. In their cores, nuclear fusion not only produced tremendous energy, but also created the first heavy elements. Carbon, oxygen, silicon, iron, all the elements essential for rocky planets and life itself, were forged in the hearts of these ancient stars. When these massive stars exhausted their fuel, they exploded as supernovas, scattering their newly created elements throughout the cosmos. Each explosion enriched the universe with the ingredients needed for more complex chemistry and, eventually, life. These cosmic recycling events also triggered the formation of new stars from the enriched gas clouds. Generation after generation of stars lived and died, each one adding more heavy elements to the cosmic mix. Gradually, the universe filled with light. Galaxies began forming as gravity pulled together billions of stars into magnificent spiral and elliptical structures. The cosmic dark ages were ending, and the universe was becoming the bright, star-filled cosmos we know today. Cosmic evolution toward complexity. As billions of years passed, the universe continued evolving, becoming more complex and interesting. Second and third generation stars formed from gas clouds enriched with heavy elements, and some of these were accompanied by planetary systems. Our own solar system formed about 4.5 billion years ago from such an enriched gas cloud. The heavy elements created in ancient stellar furnaces became the building blocks of rocky planets like Earth. And here's the most remarkable part of our cosmic story. On at least one of these rocky planets, the complex chemistry made possible by stellar nucleosynthesis eventually gave rise to something entirely new: life. The carbon in your DNA, the calcium in your bones, the iron in your blood, all of it was created in the nuclear furnaces of stars that lived and died long before our solar system even existed. You are quite literally made of star stuff. And now, nearly 14 billion years after that first moment of creation, the universe has become aware of itself through you. You are the cosmos contemplating its own existence, a brief flowering of consciousness in the vast garden of space and time. Our universe's story is far from over. The cosmos continues expanding and evolving. New stars are still being born in stellar nurseries throughout the galaxy. New planets are forming around young stars, and perhaps new forms of life are emerging in distant worlds. Scientists have recently discovered that the universe's expansion is actually accelerating, driven by a mysterious dark energy that we don't yet understand. The future holds new mysteries and new discoveries. Tonight, as you prepare for sleep, remember that you are part of this incredible cosmic story. From the first moment of creation to the formation of galaxies, to the birth of stars, to the emergence of life, you carry within you the entire history of the universe. Sweet dreams, child of the cosmos, knowing that you are both infinitesimally small in the vast universe and profoundly significant as a conscious witness to the greatest story ever told.